Hello Earth, welcome to episode 33 of season 4 of Making Cell, a series of videos where I record myself designing and implementing a programming substrate called Cell. So if you're just tuning in for the first time, I recommend you go check out the official page of the project at github.com/autocolonel/cell. I'm pasting now the link in the description. Where were we? We were figuring out, we had this sequence of transformations in the data space. So we're trying to think how the dependencies would look like. And I got quite stuck in thinking through how to resolve these dependencies, how to look for them on an ongoing basis without batching them too much. So I think the order of the day here is to look at how we would build those dependencies as part of the process of cell respond. Because if I think of it, what's left is to do for a new cell respond. Figure out how to build dependencies, dependency graph. And then the other one is figure out if deleting the results is a good way to trigger recomputation. So let's just go back again from the top here. To figure this, the dependencies, you say 11 at plus 110 plus 110, then you would say depths would be 11 and then plus 1. This is what's to the right. How do we know this? Because we found that the destination is plus 1 and the destination is plus 1. Whatever the destination is, that's a dependency. And the dependency of what? Of whatever is before the add we are expanding at the moment. If I am looking at the code, by the way, do should also be a dependency in case you redefine it. You have an if. All the options really. If, do, definition. I don't remember why I put this condition. I think it has to do with something with not, because if I comment it out, yeah, it had something to do with the order of, yeah. Yeah, I remember I had to find a way to make a test for that one. But what was it for? What was it about? Because I think I can do it a bit more mathematically if say, okay, there's 5 options. This is how it works for each of the 5 options. A bit more top down. But first I need to understand this. Yeah. Why do you think it has not been responded to yet? Good answer there. Brilliant, brilliant. Thank you for that. Okay, good. If there's no value, so it can be yeah. So it can really be a do call execution, because they're both a call. Definition execution are both calls. And then the message, that's the native, right? No, it can also be a normal reference. Yeah, this is the case of 0. Yeah, there's only 5 options, no more. I want to avoid the looking inside. I want that if I have x at if x depends on, and that's it. But no, that will never work. You do have to look at what's there. Have to walk it. If it's an if, what's in the cond and what's in the branch that you hit. But you don't depend on what's on the other branch. For the do definition, you don't depend on anything. It should be done dynamically by the execution. Varies the context. No, enables. The execution enables the context. Good. Okay, speaking of that then, how do you do it with the execution? No, I'm forgetting something here, very important at the top. It's not just about that. I mean, it is about those 2 points, but the third one is how do we recompute dependencies when things change? Do we also delete the dependencies and recreate them anew? I think that's the answer. Dependencies are also data. They should also change, be deleted and recreated. I'm thinking. If we could just build dependencies on the fly, if they are not there, and delete them when things change, it would really just be 2 things. Well, 3, but 2 and 3 are about calculating results and dependencies. Then again, if what's in the cont what's on the matched branch, do definition, only do itself. Execution at do plus the message, if there's a reference there, any calls on the steps of the expansion. I have an idea, let me not forget it. Reference, the whole thing, the whole path jumping over equals, which is the destination. the easy one. Native, a native call plus the message if there's a reference there. Constants don't change. But that's not what I wanted to say. What I wanted to say, I forgot the idea. No, wait, why are you doing this to me? Oh, yeah, I remember. Why would it make sense to put these dependencies when expanding a sequence? Wouldn't it all change always and we throw away this work? Not really. Think of this. If one of the steps depends on a variable outside, reference outside, and that reference changes, we can update the whole thing. It gives us a trigger. Now for an uncomfortable question. The inner parts of a sequence also have their dependencies. Self-similarity says we must. But if we do that, then the expansion has to have dependencies. But the expansion can just be the call itself, since the expansion affects its result. So why be concerned with that? Just do that. However, you can have internal paths inside the sequence that internal paths inside the sequence that require their own dependencies. When there's a change, we need to transitively delete two things: results and dependencies. Not all of them, just the ones affected. Whatever you are deleting the result for, you're also deleting its dependency and recomputing it. Let's review the chain of thought at the development nodes in README. Nice. How do I go about this? How to go about this? See. Why nested, why deep dependencies? This, if outer things change, everything gets recreated. Sure, but if something deeply internal is affected and only that is affected, then whole thing shouldn't change for naught, right? You could have a granular update inside, but this is not accurate. If something deep inside a sequence changes, it is to be expected that the overall result of the sequence will also change. You could really think of one call as a unit of recomputation, not just computation. If something inside changes, everything changes. This is surprising. In Adobe, which is my JavaScript library, front-end library views, we can change a child inside a parent, and the change is only there for that child. But with invitation, usually not the case, because you're summarizing the thing into one value. You could make the long analogy that the result of a call is like a hash of its expansion sequence. This feels a bit like ascending funarg, but only in that data is flowing up and forcing recomputation. What would be efficient? That if in step 2 you call and that doesn't change, you do not remove that result. You still keep it. The granular update would be to not throw away results of sequence steps that can be reused. How to go about this? Easy cases. 2 and 4. Just one reference. Sequence definition. Reference. Nothing else. Just the native. That's the arguments. I do something here. By the way, if you change a path in itself, the path implicitly depends on itself, so you also need to remove and recompute its dependencies. Yeah, that's a good one. We're almost done. So these are the easy ones. We can have a sequence in one of the branches. Also, potentially, we could even have a sequence in the condition. Why not? The sequence execution. So the whole problem really is about how to compute results and dependencies for sequences. That's it. The entire problem is that sequences can contain the other elements there, but they are only problematic in that they can also contain sequences. That's all. So a good self-similar solution can make the whole thing work. Brilliant. No, bear in mind, the first time I think of it, thinking my life. Yeah. So it's really about sequences. That's good. And sequences are the message and the sequence that expands. It's just a couple of shapes. And then the loops. What happens later with loops? But loops are also essentially sequences. There might be a couple of tricks, but the main problem is this one. Now, let's solve it. Short session today. Thank you for watching. I'll see you next time.